Yes, thank you for the invitation, everyone. As I said before, Stefan and I were a team of two, and we started this project. What we do is basically quite simple in the concept, but quite impactful in the result. We combine two technologies. One is 3D rendering, and the other one is artificial intelligence, or to be more specific, we create digital humans and we let them speak. Why do we do that? Because conversation or confidence in conversation is critical, not only in our personal lives, but also in professional lives. If you're a professional worker in healthcare or whatever, you have to have confidence in your skills and to lead effective communication and conversation. Like imagine having a difficult conversation with a coworker or an employee, where you have to diffuse a situation and resolve a conflict, for example, or you deal with someone who has mental health issues or suffers from gambling addiction or whatever. It's very hard to know what to say and how to say it if you're not trained. The same goes for situations where your, let's say, personal stakes are involved, right? Like career conversations with your superiors or a job interview. Negotiation situations, whether it's a selling scenario or convincing your teenage daughter to clean up her room. And what we kind of observed, a very critical field is patient conversations. So for healthcare professionals, doctors, asking the wrong questions, or let's rather say not asking the right questions, can very easily lead to false diagnosis and mistreatment. There was a study in 23 US-wide where they found that almost 1 million Americans suffer from negative consequences and even death because of misdiagnosis. So how do you train the skills? It's practice, 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 right? In addition, just as a quick side note, with all the AI advancement and technology and automation, there are many predictions saying that especially entry-level jobs and previously high-valued skills like computer science are becoming more and more obsolete. So people are asking, so what skills will be impactful or important in the future? And there have been a few studies from the World Economic Forum and McKinsey and others, and all of them agree that communication skills, emotional intelligence, and critical thinking will be among the top skills in the job market of the future. So the question people asked, so how do I acquire these skills, right? Or from the other end, for businesses and universities or schools, how do we actually teach these skills, right? And there is a mismatch of, let's say, theory and actual practice. So there are a few obstacles typically encountered, right? One is when you learn in a classroom situation, you are confronted with theoretical concepts, and even if you have the possibility to practice a little bit during the course, it's never enough to achieve this kind of muscle memory, right? So learners typically struggle to turn classroom knowledge into real dialogue skills. And that is also connected to cost and scale issues. Like, for example, in hospitals or medical schools, there is this concept of the standardized patients. So it's actually human actors who are invited to come, and typically pensioners or unemployed people who take the opportunity to earn a little bit of money, and they then just play a role like a patient. But it's expensive, so typically medical students get the opportunity 2 or 3 times to do that in the course of the studies, and that's of course not even close to enough to train this. And the other thing is, when you practice communication skills, it usually goes without feedback, except if you have a professional coach who gives you feedback. You resort to asking people, and depending on who you ask, you get all different kinds of feedback. So it rather increases uncertainty than boosts your confidence in your conversation skills. So if practice is important, we then told ourselves, why not use digital humans? I mean, we all know about Epic's MetaHuman technology. It's really the industry's top-of-the-line digital human solution nowadays, used in YouTube productions, film production, AAA games, and much more. And those digital humans are extremely fine-tuned, right? So not only the hyper-realistic visuals like skin textures, wrinkles, pores, you can really go close up. Even skin coloration, when you squint your eyes, certain areas of the face become more reddish. All this is already included, plus the opportunity for, of course, digital artists to customize it at will. Right? For example, for digital patients, we can simulate certain swellings of the body, or rashes, or whatever necessary. And they support full motion capture, like with hundreds of morph targets and precise control and animation. You can really have expressions in the face. With the latest installment of Unreal Engine 5.6, there was even yet another one leap forward in the realism of those digital humans. So the visual side is covered, right? So, but then the question is, how do we make them intelligent? So what we need is to get away from the, let's say, typical film production pipeline where you have scripted visuals and renders to a real-time conversation. So we need to plug those meta-humans into a conversation engine. And luckily, we have something like that. Since a few years back, LLMs became so powerful. For us, the mission was obvious. We need to bring our meta-humans to life and give them a brain and a voice, so to speak. So powering them by large language models, we can really create real-time and authentic and believable conversation scenarios. They can speak, they can listen, they can role-play any task or any role you assign to them, and play it all in real time. And how we did that, and how we were able to bring this visual communication interface to any end-user device with Arcware's pixel streaming technology, that's something that Stefan will talk about.
Yeah, thanks, Rudi. So how did we achieve this mission? Let me quickly walk you through the phases of our conversation. So first of all, the user speaks. The speech is then captured in the browser and sent to our speech-to-text service. And this service transcribes the spoken text into written text in real time. And the text is enriched with scenario context and extra knowledge that we feed into the large language model. And then the text gets to the large language model, so to say, the heart of our model. And this then generates a response in natural language. This response is then returned and turned into audio by our text-to-speech service, complete with proper tone and pacing. And finally, the audio and the corresponding animation data is fed into Unreal Engine, where we create the stunning visuals and create the meta-humans that actually speak to you. And this whole process happens in real time. Now, this was the idea, but how can we make this setup actually usable? In order to achieve this, we had to overcome 3 challenges. The first one, business needs change very quickly. So new scenarios for AI usage appear, new AI models are released. So we needed to create a system that is flexible and where components can be switched easily and quickly. So we have speech-to-text, the large language model, text-to-speech, vision capabilities, conversation context. And each of this needs to be changed within minutes, preferably, and not within weeks. The second challenge that we faced was that users do have their electronic devices with them all the time. Every one of us carries a smartphone, a very capable computer with them. But running Unreal Engine on the phone is not really an option. So we needed to make the application more accessible. And what is the feature that basically all electronic communication devices have in common? An internet browser of some kind. So we needed to make the experience accessible via standard browsers. And the third point was scalability. The system shall be able to handle potentially hundreds of users, but in times of low requests, we don't want to have hundreds of instances running, burning electricity and money. So we needed an infrastructure that scales automatically and spins up new instances in the cloud on demand without a hitch. So what did we do? Arcware to the rescue. By utilizing Arcware's pixel streaming solution, we can stream Unreal's full high-fidelity visuals at 30 FPS using just 1 megabit of bandwidth. So even users on constrained networks can get a smooth experience. And if the bandwidth is not a problem, we can scale the quality up to increase the visual quality. And using Arcware, we can deliver conversations to any semi-modern browser, desktop, phone, tablet, or kiosk, without download, without plugins, without special hardware requirements. And additionally, Arcware enables us to use their cloud-native architecture to auto-scale instances up or down to support only a few or dozens or hundreds of concurrent sessions, always with consistent performance. And one special feature from Arcware that we really came to love is direct flow. Thanks to the direct flow plugin, we can tweak custom C++ logic or blueprint settings and see the results instantly. No packaging, no uploads, no waiting, and still the testing is actually on the streaming environment where we can really test our final application. So this really saved us valuable development time and some headache. Now, where is Access Point actually used? Let's take a look at a few examples. The first one is something that Uli already mentioned before. It's in the medical field, in medical training. So we set up a system where doctors and students conduct interviews with AI-driven avatars that present varied symptoms, from common colds to complex chronic conditions. So they learn to ask the right diagnostic questions. You have probably seen the video that was running, a short video, where we don't only have a talking head, but we can show the whole body using Unreal Engine. And on top of that, we have a system in place that can give our avatars different personality features. So we can also generate cases where avatars display different moods, calm, anxious, resistant, and helping trainees to develop empathy and adapt their conversation skills on the fly. A second example for an application are job interviews. Candidates can sit down with an AI interviewer that listens to their answers and follows up with on-the-spot questions without static Q&A flow, but a dynamically evolving interview situation. And of course, a job interview is something with high pressure. So the avatars can ramp up stress with tough, unexpected prompts, mirroring real interview pressure and also cultural nuances for international professionals. Especially coming from a different culture, there's an additional hurdle applicants need to deal with. And that's why we built our avatars to adjust their phrasing and idioms to match local business cultures and to help native speakers master both content and context. And to give you one final example for an application, this is in education. Imagine walking through the Louvre in Paris and stopping in front of the Mona Lisa, then chatting with Leonardo himself about her hidden smile. That's our interactive history and cultural experiences, where museum goers ask questions and get on-the-spot personalized stories. Our picture, a grad student preparing for their thesis defense. They step up to a committee that interrupts with tough follow-ups, challenges their data, and then delivers a clear, data-backed performance report. And finally, for conversation skills training, users dive into emotionally charged role plays, diffusing workplace conflicts, mediating disagreements, or negotiating contracts. The AI partner shifts moods and tactics in real time, pushing you to discover win-win language until it feels like second nature.
Let me start first with something which, or just in general, because I'm coming from the ICE conference side, so from the 3D environment side, and I mean characters, or let's say avatars, which are animated. That's not technically in itself an environment, but obviously us as human beings, we always interact within a 3D environment. So my question would be in, let's say, in the extending into the entertainment or games with the, let's say, this notion of NPC characters, or so in the sense of developing storylines, developing characters that react within a game to certain, let's say, story arcs or whatever it is. That's one side, one avenue which I see that there's a potential. On the other side, I also see that similarly the topic of locomotion within an environment. There's also dozens of potential scenarios that could be linked to some sort of AI-related training in, I don't know, whatever it is. For those two different types of fields, did you get some, let's say, or did you research this field also a little bit? Do you see this as an extension later on to develop further business cases, or what's your, let's say, take on those two fields?
Yes, we actually kind of made a strategic decision quite early on that we're not going into the interactive game environment type of application, but rather in a more in the professional sense. So less entertainment and more training and education. So the way we set up our system is that Unreal Engine is kind of at the end of it. Most of the logic, all the code and the API calls, etc., happens outside the engine. Right? In that sense, the engine is, say, the visualizing end of the pipeline, but not the essential one that handles all the communication. If you would want to set up a, let's say, an NPC AI system, it would have to be handled from the engine itself. There are plugins for that. Conv AI, one of the most familiar ones, they're partnering with NVIDIA, which allows that to do all the communication from inside the engine. But for us, it was not something we were interested in.
All right, but I do have another question, which is of more technical, like kind of going into a little bit of a different direction. Do we get some other questions?
No, we have no. You get right. To go. Enjoy.
Right. So then, kind of in the sense of potentially, let's say, developing the whole technology stack forward. So at the moment, what you have is, I assume you have, so on the one hand side, there's a server solution which you need at the moment for the visualization, aka Arcware, right? On the other hand, you need to have a tech stack which is for the AI inference, or let's say taking an audio feed, for example, and live translating it, and then that's one aspect, kind of the audio to text, and then the third component is the let's say the text to LLM, get the whole thing back, and then translate this into an animation. So what I want to get to, so there's multiple kind of almost real-time inference phases in the whole process which you're running in real time. Now, my question would be, would it be an advantage to you to run all of the inference tech stacks on the same physical hardware as you're running the Arcware visualization? So meaning dedicating potentially part of the GPU for rendering and part of the GPU for the inference. Is that something you're thinking about, or is that something that you don't even think you need to be optimizing?
That is definitely something we are thinking about, and this might save some time actually, but this requires really a lot of optimization to get this. I mean, we have three kinds of AI models that are involved. We need something to translate the speech into text. We have the large language model, which is by far the most complex one, and then transform the text into the response text into speech again, plus generate realistic lip synchronization and face animations. So there is really quite a lot going on, and for now the approach to use several dedicated services for this was the most viable. But you're absolutely right. This is definitely something we are thinking about, and which might save us some time. Because this is was one for me as the technical lead in this project. This was one of the most complex things, to get all these systems interconnected, so that we get some real-time experience from that.
Then, shall we go for a final question for Stefan and Rudy?
Yeah,
and then,
of course.
Because Fatih actually has one, which is, how do you solve the facial expressions and emotions just with text output from an LLM? It seems like a big challenge to make it believable without motion capture. This is definitely a very interesting topic. So,
Yes.
Gentlemen.
So as Manus mentioned before, that's black magic. No, we're actually using a service that translates the text into speech, and also provides the blend shapes for these. So that's basically a result of the text-to-speech translation process, and we can more or less directly use the result from that to drive the facial animations. But for the moment, this also ties us to use such a service that provides this data. And one of the steps that we'll be going in next will be to use dedicated audio to face services, so that you can use a broader range of text-to-speech services. Yeah, but this is actually quite a bottleneck in the whole thing. I agree.
Yeah, to add to that, Fatih, of course, what you can achieve with motion capture has a much broader range of emotional expressions and micro expressions. Right? So what we have at the moment is a much smaller range that we can cover. There is, you're probably familiar with NVIDIA ACE, the Avatar Cloud Engine that kind of is the cloud service from the previous audio to face module that they had in Omniverse, which uses also neural networks to extract emotional meaning from audio and then translate it into the corresponding facial expressions. But for us, it's basically a cost efficiency question as well, because having the latest and the newest and the best technology always comes with a price. If we want our customers to be able to have a reasonable price range, where we kind of have found a sweet spot where it's still kind of there is expression, but it's not let's say too sophisticated.
Good. Thank you, guys.